Hi, everyone. This is Aaron Larson, executive editor of Power Magazine, and you're listening to the Power Podcast. On today's episode, I'm joined by Mike Richter, the president of Brightcore Energy. And many of you will probably recognize the name because Mike was also a professional hockey player for 15 years with the New York Rangers, won a Stanley Cup and was a three-time All-Star in the NHL, and also played on 3 Olympic teams as well as World Cup gold team. So, Mike, it's really great to have you on the program. Can you tell a little bit about some of the experiences you've had through the years and kind of what led you to getting into the energy industry?
Aaron, yeah, sure. Thank you so much for having me. I'm super excited. I mean, I love talking about this, and it's why I'm in the industry. I've always had an interest in the broader environment, and I think energy in particular is so not just crucially important, but it's got its own kind of interest level in my eyes anyway. And so even when I was playing, you live a very sheltered life in a way with a lot of time on your hands in an odd way if you can imagine what you're doing, and that is preparing as much as you can for the next game. You're playing the game and then repeating, recovering from that and repeating. And so I was a goaltender in my athletic career, and you usually roomed alone. So it was, you have this great team around you, and a lot of, great teams are usually tight, like a family. You go out to dinner, you do all the fun things, but there's a lot of travel time, hours going across the country, nights where you're resting in your room alone. You can only work out so many hours of the day. The rest is recovering and prepping. That's where I did a lot of reading about environmental issues, resource constraints, energy systems, and I always had an interest in this. So, you know, I was fortunate enough to have a first career, and now this has really been the focus of my second career. So it doesn't feel particularly odd to me because I've always had an interest, but it is a head scratcher for a lot of people when they first meet.
Sure. And can you talk a little bit about Brightcore Energy? I mean, there's probably a lot of people in our audience who don't even know what the company does or what you're focused on. So maybe tell a little bit about the company and some of the projects that you guys have worked on.
Aaron, yeah, this is an important question. I love our mission, and that is we deal only in commercial, industrial, municipal buildings. That is to say, kind of anything that is not residential. It's a broad mandate, but it's specific because of the scale. And we just try to make both existing and new buildings operate better. That sounds pretty straightforward, but it gets complex because of everything from the financing of to the lack of knowledge, the split incentives from owners to tenants of buildings. There's many, many hurdles, and it's always changing because technology improves and applications change and regimes come in on a federal and state and local level that change what's possible for better or for worse sometimes. And so you really, it is day to day, week to week, kind of staying abreast of what the opportunities are and how they've changed. But the kind of macro trend is we have a limited amount of resources out there and what appears to be almost an unlimited appetite to use them, whether it's food, water, fresh air, but in particular energy. So if you can approach how we run our society with more efficiency as it relates to our energy use, transportation, buildings, in industry, of course, you're going to start finding that you have a valuable solve. And we've decided to look at the building space. In a place like New York, we're centered right outside New York, both in Brooklyn and Armonk, New York, our office space. But a place like New York, the greenhouse gas emissions from the built environment can be 60 or 70% of the city's emissions.
Hmm.
So if you're starting to make a dent in that, you're having a significant improvement in terms of air quality and greenhouse gas emission reduction. So it's exciting. It's constantly changing, and it's crucial that we get it right. So that is our company's mission, and we really do it through 3 technologies: lighting, solar energy, and geothermal, otherwise known as ground source heat pumps. And I'm sure we'll get into that. The difference between the energy production geothermal that's primarily out west in the United States, and a simple heat and cold transfer that is effectively a radiator in the ground. It's what we do. Why do we do it? Lighting's great. You can save 50% on your lights if you go from LED from a T8, a traditional lighting, an incandescent bulb that is, and that's great. But lighting represents probably 10 to 20% of a building's draw. So you can change every light bulb in America, and we should, to more efficient ones, and continue to change them again as they get more efficient. They're longer lasting. They have real tunable color temperature. These are better products, but you're not going to move the needle as much as you'll want. And solar is beautiful. It's clean. It's reliable. It's long lived, resilient. Great things, but it doesn't apply everywhere. When you're talking about a place like New York, it's very difficult given the postage stamp roof size and the huge load that some of these tall buildings have. So the elephant in the room has been, as we got this company up and running over the last 12 years, the HVAC systems, the heating and cooling of these buildings. And the massive draw that it takes on a hot day. It's about 90 degrees right now. There's a lot of energy being put into the buildings to keep people cool inside. as these heat waves come, actually keep them alive. So if you're going to address that, you're doing something important, and that's really where our focus has been, particularly in the last few years.
Understanding how geothermal works is important. And you mentioned the fact that there are utility scale plants, out in California. It's very, very popular and easy to implement. In an area like New York City, what do you have to do? Like, how far down in the ground do you have to go? And how do you manage that with all the other things that are underneath the roads and buildings there?
Great question. Yeah, we typically go between 500 and 1,000 feet down, and just to highlight that against the production geothermal, the hot rock geothermal that can go up to 10 miles below the surface, and you're truly hitting hot rock, and either there's a water source there or you inject water, and that creates steam, and you capture that steam and turn a turbine, no different than you would on a coal plant or gas peaker or a nuclear plant for that matter. You're using steam to turn turbines to create electrons through a dynamo. We don't create electricity, we use it, and we use it very effectively and efficiently, but we're really, the metaphor that I sometimes use is you take your warm hand and put on a cold beer. That beer gets warmer through just the thermal movement, and your hand gets cooler holding onto that hopefully ice cold beer. And so the ambient temperature of the ground about 4 feet down below our feet here in New York is 55 degrees year round. And so in the summertime, you think of mechanical lifts. You're taking a heat pump as you would with your refrigerator, and you're trying to move 55-degree air and cool your home. That makes a great deal of sense. We have pipes in the ground that have a fluid in it, and it goes down and comes back. It's a closed system, and you're just transferring heat the whole way. So if that liquid goes into the ground at 90 degrees or 100 degrees Fahrenheit, it'll come back at 55 if you do it right. In the wintertime, it could be 0 degrees Fahrenheit out. That liquid's coming in at a very cold temperature. It transfers the heat and the cool through just thermal conductivity and back into the heat pump, and you're going from 55 degrees Fahrenheit to, say, 70 that you might want your house to be comfortable. Pretty straightforward and very, very efficient and effective, particularly, and this is key, at the extremes. Air source heat pumps are excellent, and they continue to get better. And we do a lot of hybridizing of systems where we deploy both, but in and of itself, there's limitations. So when you do have that polar vortex coming in, and it goes down to 0 degrees Fahrenheit for a number of days, you're using an enormous amount of electricity. And think about this. In the summertime, when you have the heat domes like we just experienced across the U.S., a city like Chicago will see a massive spike in their electron use, in their energy use from the air conditioning. Well, as we electrify all buildings, you're going to see a similar spike in the wintertime. And running out of capacity in the winter in Chicago when it's 0 degrees Fahrenheit is deadly. And so Utilities understand this, and a solve for that, of course, is peaker plants, but they're very expensive to build. The most effective and efficient electron you can have is the one you don't use. And that's what efficiency is about. We're trying to just lower those spikes, and we really, really can do this. And in fact, we've put in systems now that are getting paid time of use pricing just because it effectively can go in 15-minute interval data, preload certain boreholes with heat, for example, when we know there's that thermal event coming. Say Friday afternoon, there's going to be a polar vortex coming into New York. We will preload boreholes with heat, extra heat, and extract it when the demand is most, and therefore increase capacity for the system. It really works hand in glove with the utilities who have been very, very good to support us. So this is a simple concept that hand on beer, but can get very complex and very nuanced in its application.
Yeah, I love the analogy with the beer because I think most of the people in our audience can understand that quite easily. What do you think is maybe one of the biggest misconceptions people have about geothermal? Is it the fact that maybe they think it can't be used in certain areas and isn't available to them, perhaps? Or what is it that you run into most often?
Really good question, and I'm glad you asked. I think the first one is the efficacy. They don't understand how good this is. It's the single most efficient way to heat and cool a building known to man. And the big question is, first, can you apply it everywhere? Secondly, how expensive is it? And I think that that second question is a tough one because people say, I've had sophisticated people, developers and whatnot say, yeah, we're building in New York. We would love geothermal. We use that out in the college somewhere with a lot of land and it was great, but we're in the city and it's densely populated, can't do it. That's not true. They've been doing that in Europe for decades now. And we can get into this later, but we have an office in Stockholm for specifically that reason to get that tech transfer across the Atlantic and start deploying it here. It's commercially proven, it's exceptionally robust, resilient. And as we get scale, the price just plummets as you saw is continuing to happen in the solar industry as it starts to get scale. We're in the early days. It's about 1% market penetration here in the States. It's I think 20 to 25% in Scandinavia. They're 20 years ahead of us. So they've gone through a lot of these same questions and answered them with an explanation point. This works well. So I think that's the big thing. People don't even know it. We go to developers, sophisticated ones, and they haven't even done the analysis to see if that's a potential solve for their heating and cooling needs when they're building a new building. And I think, well, bring us along and you'll start to see this. And as these projects get up and running, people will get educated and understand it, and the perceived risk will come down. But these are the maintenance is very low. They're rated from 75 to 100 years, that basic radiator that we put in the ground through the borehole system. And the mechanicals are all brought inside the building as opposed to having the condenser units and all the mechanicals on the roof exposed to the elements and loud and unsightly. They're in the building, they're quiet, and they're basically a lot more protected.
Mhm.
So the maintenance is easier and the longevity is more. But the final question I mentioned is the price. And it is expensive to do. The IRA effectively can cleave 40 to 50% off of the front end cost. And what's beautiful about it is putting the boreholes in the ground and having the whole thermal system in the ground and then the mechanical system, both are subject to this tax treatment that can be, it really starts with 30%, another 10% for American percentage of American made technologies, which is pretty easily hit. And if it's in an economic development zone, you can get another 10% up to 50% off on the entire system. So mechanicals are included. If you were to do say an air source heat pump system, it's not. So it can be at par or even less or more, but operationally, it's almost always cheaper to run a geothermal system just because the coefficients of performance blow everything else away. And so that those three things, does it work? Yes, it's very robust. It's been proven. It's a wonderful technology. Can you apply it in different places? 100%. The technology, as you mentioned, with all the utilities and subway stations and infrastructure in the ground in a place like New York, you just have to have the technology to be very precise where you're putting these holes. And we have that, and it's been proven, and we are doing it as we speak. And then the final thing is the price. Look, the two founders of our company were 20 years apiece on Wall Street. They underwrote all kinds of financial products. And so they understand how to price an asset. And that's really the lens through which we look. I can knock on your door all day long and tell you how green it is, how sustainable, what the coefficients of performance, but the average person's trying to put food on their table and they need it to be cost competitive, better. And that's really what we're selling as savings.
You mentioned a lot of things in that discussion. One was the IRA, which is the Inflation Reduction Act. Is there any risk that geothermal may not get the benefits that were previously available, or is the Trump administration supporting this as well?
The Trump administration is supporting this. There will be a lot of bloodshed when it comes to other, sustainable energy products like solar and wind, unfortunately, because they work, they're great, they're cost competitive, but it seems to be an ideological line in the sand that they won't be supported for as long. They're going to sunset. So there'll be a rush to getting as many projects done as possible before the sunset kicks in. So yeah, that'll affect them. Geothermal has been left slightly better because the incentives remain, but it looks to me, and we're still figuring this out, an enhanced ability to have third party ownership, like the PPA models or energy as a service, where the tax treatments can be spread as efficiently as possible. It's one thing for the client to take it, it's another thing for the vendor to take it. It's a wholly different animal for the investor to take it. And that opens up a lot of investment opportunity, which means competition, which means cheaper prices. And it's a great thing. So
Mhm.
the short answer is geothermal's intact, and we're happy because when it was unclear, people get worried and they just stop. That they put projects off. And we've been smelling a lot of that over the last year because there's been whiffs of, hey, this thing could go by the wayside. It's remained intact, so it's all systems go now for us.
And from what I understand, these systems can actually cut energy use by 50% or maybe more. Is that accurate? And if that is true, that's got to be very helpful in the payback period to basically make these economically viable systems. Is that true?
Yeah, that is true. We look between 30 and 60% savings, depending what you're replacing. And also, this is an air system, air force through ducts. And, if you're doing a deep retrofit, fine, you're reconstructing the building. But to swap things out, certain buildings that just have, say, baseboard heat, you start incurring a ton of expense when you're really doing a big bunch of duct work. So we're judicious about where we put these things. But like I said, it just comes down to the cost benefit analysis, and it is absolutely competitive. And you really have to look in a slightly different way, and that's a life cycle analysis. What's the capex? What's the front end cost? What does it cost to operate this thing over 20 years compared to what the front end cost of whatever the incumbent would be? And what does it cost to operate that? And so I think when you're looking at that way, it's a much more comprehensive analysis. It comes out beautifully. And truly this is, again, we're selling savings, and it's got to be there. You're also saving in a way just the non-financial attributes of this thing. It's quieter when you're talking about a campus. Some of these condensing units can be quite loud. Some of the maintenance that's attributed to it, not just because it's subject to the elements, but the Legionella and whatnot. When you're talking about a healthcare system, you better be all over that. And if you get it wrong, it's a real health hazard. These are fairly simple systems once you put them in, and we are really proud of the fact that we have the ability to have operations and maintenance. We can monitor these systems. We have our own proprietary software. I was just looking at a project we did downtown New York and what the coefficient of performance was yesterday, and it was pretty great. And on a hot summer day, this thing's humming along really well. Why is that important? Because you can optimize the system. If I don't know what, I can promise you all kinds of things and I put it in there and walk away, buyer beware. But I can look at this thing in real time and say, it's a hybridized system, and we have the ability to tweak this in a manner that really uses the least amount of energy and gets the most comfort per dime. And just in speaking of that quietness, that lack of maintenance, and truly the modulation of temperature swings. I live in a 100-year-old house in Connecticut, and there's hot spots and cold spots and loud noises when the furnace used to turn on. I have converted, and I am shocked about, I'm in sales, and I think I missed the boat on this sometimes. It is very quiet and it is very consistent, and you just have a better living environment. And I will tell you, it's like the first time someone drives an electric car, the acceleration is not just forceful, but it can be very smooth. And so you start to have a better experience, not just a one that costs less money.
And you mentioned that it takes, a very precise drill and a lot of precision to put these systems in a urban area such as New York City. Can you talk about what that installation process looks like and some of the obstacles that you might face in working, within the city?
Well, permitting used to be really difficult, and they've understood the efficacy of this, and I think they're working hard to try to make this a little easier. One thing we'd all like to see is a standardized regime of permitting across states and different jurisdictions. It can be quite different from one state to another. And in the tri-state area, you can be in and out of state markers pretty quickly. But I think the first thing is, you're going through the subfloor of existing buildings. You have to make sure that structurally there's no issues there. And that can be done, I don't want to say easily, but very accurately. And you have to have the ability, not just the equipment, but the master drillers that understand this. When you're going through formations like Manhattan schist, it's very stable. It's great thermal properties. So when you put a borehole there, it transmits heat and cold very well. So you can be really efficient by this. When you're digging in other areas, as you get out to Long Island and whatnot, there's unconsolidated material, and you can hit big formations and glance off. And more like we're borrowing from the fracking industry and the oil and gas industry. They've been in the business for a long time, and that breakthrough in directional drilling for fracking was a material change for the industry. And we're getting the same thing going on, piggybacking off of a lot of what they've done, and the ability to go down, say, 7.5 degrees and then move it after 100 feet to a slightly different angle. And the more control and precision and certainty you have of where that drill head is, the more opportunities you have to put geothermal in, because navigating through water tunnels and fiber optic cable and foundations matter, obviously. So the sophistication of our equipment and our ability to monitor where and the precise guidance of that drill is absolutely paramount. And we're really dialing that in as an industry. And we feel like we're one of the leaders in that specific area as a company.
And in the opening, you mentioned that you're mainly focused on commercial and industrial. I can imagine that big housing projects, for example, in a low-income area might be an opportunity. Is that something that you are looking at, or is that something that maybe you have done in the past, or where do you stand there?
Yeah, Aaron. Well, we do municipal work as well, and we're in conversation with a number of towns. One of the reasons we love universities and towns is the hold period is maybe forever. So you can amortize across forever pretty well and make the numbers work. If someone said, "Hey, put this $20 million system in, but I want to, be whole in 3 years," pretty tough to have a 3-year payback on that. We have seen though, certainly in the 4-year range. So this is not impossible. But back to your original point, one of the problems with green energy and sustainability and a lot of this movement, it's vulnerable to, I guess, the claim that it's only there for the elite. And so if a wealthy person puts solar panels on their third home in the Hamptons, that's great. And it helps all of our calls, but it's not open to the average person because it's just too darn expensive as a new technology. We're working on a project down in outside of Washington, D.C. That's a former freed slave colony. It's historically, economically depressed area, overlooked community, and because we're doing a thermal loop, and just to give a little bit of history, your thermal loops are basically just saying, look, I have a series of boreholes here, and I'm putting this ambient temperature loop, not unlike a gas line, through a neighborhood or two neighborhoods or across a campus. And you can imagine a campus saying we could do the library and leave it at that, and it's a closed system on the library, but we could do the library and hook it into a loop that goes to the campus and hit the gymnasium and a couple dorms and some classrooms too. And you just add efficiencies because there's sinks and sources of heat. So a hockey arena may blow out a lot of heat, or a data center blow out a lot of heat because they have to keep it cool. But a laboratory needs to sterilize things, and they need massive amounts of steam and hot water. And so this system becomes very, very efficient. Your waste heat becomes my, I will purchase that. And that will be an incredibly effective way to do this. The larger the system, the more efficiencies there. We're doing this across a few neighborhoods outside of DC right now. What I love about it is not just the efficiency, but the access to these cutting edge materials and technologies and solutions that are open to a community that otherwise is often overlooked. And so they're participating and helping, not just taking, they're helping balance a system and participating in the greening of a whole series of that town, even though they're low income housing and they normally can't afford to get this access to this. So I think that's a real kind of democratization of participation for sustainability. It's a really kind of, I think, very healthy and exciting thing.
Mm-hmm. Yeah, it sounds like a project that you can be proud of. Are there others out there that you could share about?
Honestly, I'm proud of all of them because all of them take a ton of work and understand what we're doing. I mean, this is not easy stuff. And it's very easy for vendors like myself to say, why isn't everybody doing this? They all should care about this when they get up in the morning. Look, we all have jobs and not everybody's up on the technology. And when you're not privy to this as we are, it ends up becoming more of a burden because you're saying, well, what's the risk? I don't know. My neighbor doesn't have this. Why am I the guinea pig? And as we start to get a few more of these projects done and get them out in the media and talk about them on great shows like yourself, it changes what people's expectations are. And really, it's not that people don't want to do it. There's just a lot of inertia. We do what we've always done. The uptick in cars, I mean, it's been incredible since Elon Musk has put out his electric vehicle and then Ford's come out with one that can serve as a backup generator to your house. I mean, it keeps leapfrogging each other and getting better. And the rate of uptake is impressive. But EVs still make up only less than 10% of our fleet of automobiles. So it takes time. The scale of moving this ship going from one direction to another is daunting. And so every light bulb changed, every geothermal well dug makes a difference. But boy, it feels sometimes like it's a drop in the bucket given how much history there has been and comfort there has been giving her incumbent technologies. And let's be clear, fossil fuels have been great. They function immensely well, but we do have a problem, and it's making the world less habitable. And so we have to start to figure out ways of maybe using fossil fuels for the plastics that's in everything, and finding heat sources and sources of cooling that are less destructive. And we have one here. We love competition. We want to beat out our competitors on every job, but every good job that gets in the ground helps the industry and helps the world, really.
Do you find it preferable to do these as new installations in a building that's going up, or can you retrofit older buildings and achieve similar goals?
It's slightly more straightforward. You have a blank slate when it's a new build. So you can design around the reality and the needs of this technology. Retrofits always have inherent limitations. This is the size of the plot that you get to deal with. This is the existing ductwork. Do you change it or do you keep it? Here's how big the mechanical room is. Here's where it's placed. How do you put your manifold and connect the ground radiator, the bore field to the internal mechanicals? When it's already set, quite literally in stone sometimes, it can present challenges. So in one regard, it's a bit easier to do new builds. The flip side of that is I'm more excited by the retrofit market because in a place like New York, 80% of the building stock is going to be here in 20 years, say. We're not just blowing up these buildings and putting in brand new ones. You're not taking down the Empire State Building and putting the LEED Platinum building in its place. You're going to have to retrofit that thing, which the Malkin family has done admirably. We will continue to hit every building that we can, and at some point, some dinosaurs are going to have to be extinct, and new buildings will come over it. But I think the vast majority of our work will continue to be retrofits. End of useful life is an opportunity to improve your performance. I don't expect people to rip out their oil furnace overnight if it's still got 10 years of life left in it and go to, a green solution. It's just too expensive. But when that thing is dying, you better hope that people start to do their homework on a residential and a commercial level to understand what the options are. And a good portion of what we do is education. This is what we're capable of doing. Here's how it is. Here's how much money it's going to be. Here's how much you'll save. Here's how easy it'll be. Here's how robust it is. So people don't know that off the top of their head. And it's a very, again, young industry. And so we have a lot of work to do. But I'm really hopeful, not just for my own enterprise, but for the world, for national security, for all the right reasons, for quality of life. These asthma alleys that you get in places like the Bronx, a lot of that is from old buildings that are quite inefficient, and they're not just putting out greenhouse gases. There's no argument that particulate matter is extraordinarily harmful to human health, and this is something that you need to think about. You could take whole communities when you have these thermal loops, like we're doing in DC, and suddenly the air quality is dramatically better, and it's a noticeable, measurable difference. So it's not just greenhouse gases we're talking about. It's the risk for diabetes, stroke, heart attack. These are known carcinogens and real enemies to public health that have enormous consequences, just not only in human lives, but in financial terms. So yeah, there's a lot of benefits that accrue to the community. So if I'm your neighbor and you put it in, I should be thanking you. You're not the only beneficiary.
Sure. I know you mentioned early on that utilities are also behind you on this type of thing because it can benefit them in many ways. For example, maybe they won't need to put in new transmission lines to carry more electricity to power, heating and cooling units in the city. Are you finding that they have any programs out there, or are they helping you raise awareness to the solution and kind of promote this sort of technology to their clients?
Yeah, it's a great question. Look, we've been doing lighting and there's great programs, utility territory to utility territory. It differs for lighting for all kinds of efficiency, like variable frequency drives and things that do make a material difference, but they're usually smaller. Solar as well. You see, that's more kind of state driven. But I've been really impressed with the utilities. We work with all of them in every territory we go to because it's usually pretty big clients, and they have an interest, exactly what you're saying, in being very aware of what their capacity challenges are. And if we can start shaving those peaks, it means that they can avoid some major investments. And I think you're starting to see some pilots where the utilities are putting in what is in effect the utility. It's a geothermal loop. That's a utility that's owned by them. It's put in by them. It's financed by them, and you hook into it no different than you would on a gas basis, where you have some kind of connection fee. You retrofit your house to accommodate that fuel source. In this case, it's just hot and cold water, and you run a heat pump out of your house, and they charge you electrons. It's a really beautiful, kind of elegant and safe system. These things don't blow up. They're very robust. They are stable in the ground. There's a lot that lends itself to that. But again, changing over to this is not an easy thing. But you're starting to see some gas constrained places. We've gotten in this country a bit, this has become a politicized thing, as unfortunately a lot of things do. And I think it's almost silly when you really think about it. Conservatives and progressives want clean air and fresh water and affordable and consistent electricity and power for the buildings, for the kids, for the schools. That's not really in debate. And what's more American than progress and the spirit of entrepreneurship and innovation? I mean, we're not still going horse and buggy, right? Automobiles eclipse that. And there's lots of people worried about it, clutching the pearls on that one. And certainly, not to make light of it, jobs will be lost, but jobs will be gained. And this is progress. And that whole idea of innovation moving forward and improving the quality of life. That's what we're doing here. And I really do believe in it. And I think it's a very difficult thing to understand because we get used to what we're used to. But change is kind of the name of the game. And if something came along that would be better to heat and cool a building than geothermal, I am I am all over it, and so is our company. But this is the best that we've devised right now, and it keeps improving because of different technological, aspects of the drill, of the software, of the AI that's helping design these systems. Yeah, we have a long way to go, but we're in the beginning chapters of this, and it's going to, I think, really change your life for the better, not just in terms of the financing, but just the quality of the air we breathe and the risk that comes with some of what we're getting away from.
And I guess, I'd like to understand how we can improve the adoption of these strategies. And you talked about scale. As you get more and more of these out there, the costs come down, which we've seen with solar and wind, over the past decade. What else could potentially help drive this forward? Is there new regulations? You talked about the IRA and how that's supporting some of these installations. What else can be done to help promote this and really get it to take off?
Education, number one, government taking that first step. Somebody has to be that first mover, and we have them, right? We have some really interesting clients. A lot of universities have their own mandates about sustainability, so they're very open to explore this. Of course, they look through the financial lens as they should, but we are doing a lot of work on college campuses, K through 12. Municipalities are really starting to get into this, and that to me is going to be a very important kind of advertisement for how effective these systems are, and just to get people to experience it. I'm always impressed when I take somebody to a job site, and I can give them flyers about what we do and explain all day long, but then they get on the site and they go, "Oh, wow, this is where you're digging the ground. There's a physical drill making holes in the ground and drilling into this thermal mass that's going to affect the building above it." And when they experience it and go down and see where the manifold comes and into the mechanicals, it becomes real for them. And so, yeah, I think the more we can do podcasts like this and lunch and learns and education and of course tours of existing things. Change is hard, and change for the better. There'll be a tipping point where everybody wants to get on that. But in the beginning, most people don't want to be the laggard, but they don't want to be the first in. And we're still, getting from 1% penetration to 2% is still early days. But the biggest thing is just having this kind of complex understanding simplified for them. And what they need to know is it's really applicable in most places. It's way cheaper to run. The life cycle costs are lower, and it's exceptionally good for the environment. And it's a great experience. So I think people start getting the word out, but it's hard. These are systems that when you put in that system in your house or your factory that you just built, you're not thinking about this for another 2 decades. So it's kind of crucial for the end of useful life moments to at least have this in your field of vision.
Well, we've been talking a long time, a lot longer than I expected, but I've got one more question for you, and that concerns policies and barriers. Is there anything that you would change if you could that might accelerate geothermal adoption and the use of these systems?
Great question. There's a few things. It's a very fragmented space, if you will, right? So let's just say that you're a school system and you say, boy, I'd like to be green. What are my options? So you're going to hire an advisor. An advisor is going to give you advice, usually for a fee. And at some point, you're going to start making decisions on this. Well, there's somebody's got to design this thing. Someone's got to oversee the construction. Someone's got to operate it, or at least teach your men how to do it. And historically, in this industry, because it is so young, there's specialists in each. There's an advisor. There's an engineer that does the design. Perhaps someone else is procuring it. There's the construction manager. And then there's the very special driller. And as this industry matures, you'll start to see a smoothing out of offerings. And we've really tried to do that. It's been a long time. It's expensive. It's difficult. But we've, I think, taken a real important step to making this thing, that easy button that Target had, I think it is for a long time. You should be able to get the advice on what this thing is. It's quite fine to have a separate advisor to cost check and everything else, and maybe even run an RFP. But a group like ours, I think the industry is moving toward an integrated approach where right from the go, no go consultation through the design to the procurement, the drilling, and the operation, when it's seamless and there's communication from those different kind of often siloed parts of the whole, there's cracks in the lineup and things can fall through those cracks. We'll start to get more integrated and having this knowledge within one throat to choke, as they say, is enormously important. That's one. Number two, we need workforce development. I can go out and buy all the rigs in the world and cutting edge technology, beautiful, exciting, interesting things. But if I don't have somebody who's a master driller that knows how to do this, we're not getting many projects done. And these are tremendous, they're high paying jobs. It's exciting to be part of a new industry. But anything on a federal level and a state entity that can start to grease the skid to get more people understanding that there's a huge need there. And it's a really vital work and it's a choke point in the industry. That is one. And then maybe a final one, which is similar, but just getting that consistency of policy standards. IGSPA, the International Ground Source Heat Pump Association, is doing a great job of saying, here's kind of the standards, industry standards, and we need to adopt them everywhere. This is always the case with new industries. You saw it in solar. You saw that same kind of smooth integration from the financiers to the boots on the ground in solar. We're doing the same thing in geo, but we need to have consistent, I guess, policies regarding it and what the tolerances are, what the consistency of expected materials are. That happens with the maturity, but the quicker that happens, the quicker we get to scale.
All right. Well, Mike, I'm sure you are very proud of your hockey career, and as well you should be. But I think you can be even more proud of what you're doing today with Brightcore Energy and developing these geothermal heating and cooling systems for buildings in New York City and elsewhere, because I think you're making a difference not only in the emissions, but in the efficiency and helping the world and helping the people and the communities that they're installed in. So I think you're really doing great work, and I hope that anyone listening to this will consider your systems and consider putting them into any buildings that might be in need. So thank you so much for your time. Is there anything we haven't talked about that you really want to mention before we wrap up here?
No, I think you really nailed all the questions. I really enjoyed our conversation. I think, I'll end where you started, and that is, what do you want people to know? I think people fear what they don't understand, and they can't know these things unless they experience them a little bit. And this is something worth at least pursuing and learning about how effective it is. It's happening all over Europe. It's happening in a lot of the parts of the United States, but it needs to be happening at greater and greater scale because the benefits are not only for the owner of the building, but for the larger community are significant, both financially and otherwise. So yeah, this is something that needs to be out there and anything you can do to educate yourself. And I really want to thank you, Aaron, because that's what you do is educate the public. I hope it was entertaining and educational. I really enjoyed myself. So thank you.
All right. Again, for listeners, I've been speaking with Mike Richter. He's the president of Brightcore Energy and a Hockey Hall of Famer. So thank you for joining me, Mike. It's been a pleasure speaking with you.
Awesome. Thanks, Aaron.